Hey everyone, welcome back to the channel. In this video, I'm going to take you guys behind the scenes of one of the interesting data engineering project that I worked on. YouTube Comment Sentiment Analysis Pipeline. Completely automated, fully cloud native, and built on Google Cloud. In this project, we are going to build a real-time data pipeline that collects YouTube comments, analyze the sentiment using natural language processing, and transforming them into meaningful insights, completely orchestrated. To make it production grade, I started with Terraform and Ansible for infrastructure as code automations. So every part of the environment can be deployed using few commands. And I used Jenkins to create a CI/CD pipeline to keep everything in sync, from the code commits to the deployments. These are included in the skills that the top big companies like Google expect. For the cloud part, this project runs entirely on Google Cloud Platform. PubSub, Dataflow, BigQuery, Cloud Composer powered by Airflow. In short, this project doesn't just analyze YouTube comments. This is a fully scalable, production-ready architecture. If you're into data engineering, cloud automation, or you just want to see how these tools work together in the real world, stick around. I'm going to break through all the components step by step. Let's begin. It is always good to have a plan before getting into action. And this is our plan. This is the architecture of our project that we are going to follow in order to complete this project. And our project is YouTube Comment Sentiment Analysis Pipeline. We are going to build a pipeline which pulls the comments out of a YouTube channel, of a desired YouTube channel, and we track the sentiment of every comment. And at the end, we will see the ratio between negativity to positivity of those comments. And yes, this whole pipeline, this whole infrastructure will be built using Terraform plus Ansible. Just in case if you don't know about these tools, these are the IAC tools, infrastructure as code. We basically use these tools to create resources and configure them without using the UI. You might wonder, isn't it easy to create these resources and configure them on UI instead of using code? But here's the thing. If you use UI, you cannot duplicate it unless you do that process again into another platform, another environment. But Terraform and Ansible, basically IAC offers you this. You don't need to do the whole process again. You just need to run these particular codes and these resources will be duplicated into another platform or another environment. It's that easy. So that's why we use IAC. It just makes the duplication easier. And we use Terraform plus Ansible. We'll be using Terraform to create the resource and Ansible for configuration. And because we will be using IAC, you won't see me doing much of a process on UI. Most of it will be in code. Yes. Getting into the pipeline. Like any other pipeline, this pipeline starts with the data source. In our case, it will be a YouTube API. We will be getting a channel ID from YouTube interface, and then we'll be using YouTube API, which is provided by GCP, to get the comments of that particular YouTube channel. And then we will be running a function in cloud using Cloud Run. And then that Cloud Run passes the data from this API to PubSub. PubSub is used for data streaming, which is offered by GCP. So PubSub is like a data streaming platform. Like as even hubs in Azure, we have PubSub in GCP. And then this stream data will be pulled using a data flow. We'll be pulling the data out from the PubSub and then transforming it and cleaning it and then storing it into BigQuery. This whole data processing is done using Dataflow and Beam as a processor, Apache Beam as a data processor, and this Dataflow as a streamer. And then this clean data will be gone through a particular code that analyzes the sentiment of every single comment and adds the sentiment score at the end of every row. And then this data will be pushed into sentiment table in the query, BigQuery, which is our data warehouse. We'll be using BigQuery as our data warehouse because this is the GCP environment. BigQuery is basically a data warehouse in GCP. So we'll be storing the business ready data, which has a sentiment magnitude. You'll know about sentiment magnitude later, but that is like a number, a value that shows a sentiment, whether the sentiment is negative or positive. If it's a positive, how big of a positivity is that? So we'll be storing the data which is business ready in BigQuery, and then this business ready data will be taken out and used to create the visualizations in Power BI later. And this whole process will be orchestrated using Composer, which is a GCP tool, along with Airflow to orchestrate. And after creating the whole pipeline, we will be using the CI/CD with Jenkins. If you don't know about CI/CD, CI/CD stands for Continuous Integration and Continuous Development. It is basically an enterprise level practice to do CI/CD. So whenever you push or pull something into GitHub, it runs a particular steps which has the test that needs to be done. So if any one of those tests fails, that particular push will be rejected, or else it will be pushed into the GitHub repository, basically. And yes, that is the architecture of our project. Now, one more thing I need to mention. I'm not going to, like I said, I'm not going to use the UI. I'm going to use the codes, which means there are a lot of codes in this project that I can't actually write them on camera and explain it to you. So I already have those codes written, but while I paste those codes, I'm going to explain about them and what's actually happening in that code. So you will know why we're using it. And also I have a document. I will be sharing this on GitHub, or I will be posting the link in the description for this, which says the procedure of you need to follow in order to complete this project. This is the procedure. All the files that I'm going to use in this project will be documented in a GitHub repository, and the link for that repository will be given in the video description. That GitHub repository looks something like this. It has every file that I'm going to use now, from A to Z. And yes, stepping into the procedure, our first step is to create a project in GCP. In case you haven't created an account before, you go ahead. GCP offers a free trial account where you just need to put in your debit card or credit card details in. They won't charge you anything unless the free trial period is over. And they offer you $300 worth of credit, which expires for 90 days after you create the account. So you can use those credits to build projects. This is the homepage. To create a project, I already created one. You just need to click on new project and name it, assign it to an location or organization. I'm not going to do that because I already have a project created. After that, you just need to click on here. This is a project dashboard that you'll land on for any new project that you create. And yes, we're done with the first step. The next step will be creating the tree. Tree in the sense creating the repository inside the Cloud Shell. You might wonder, because this is a cloud-based project, I don't want to use my local machine to run any code. So the files and the codes that I'm going to run will be running on Cloud Shell. If you take a look on the top right, you'll see this symbol that says Activate Cloud Shell. Click on it, and the terminal pops up. If you're opening it for the first time, it asks to authorize You click authorize. Yes. It comes with a terminal and also a code editor, which also have a file manager right here. It just works like our local machine, but something on cloud. We can save our files, we can run commands in terminal, everything. Yes. To create a tree, to create the repository, I have a file created which has all the commands to create the whole tree at the same time. So you don't need to waste your time. Go to commands folder, tree create, copy this all commands and go back here, paste it and hit enter. That's it. It is that simple. Now, when you go to editor on the left pane, you can see everything, all the files and folders created, but they're all empty. All the files and folders are empty. You have to put in the code in and save it. For now, let me show you. See. First, let's take a look of what we created. Here, we used mkdir. Mkdir commands to create a directory. We created a directory named GCP comments GCP, and then we run cd. cd stands for change directory. And then when we run cd, we're going into this folder, the repository that we just created. We're going into this. Now here we created Ansible and then another folder inside Ansible that says group vars, and Ansible, another folder named playbooks. And then we created app, DAX, Dataflow, ML. All these are folders. And then infra, env, dev, infra modules, BigQuery, Composer, IAM, PubSub, storage. So yes, basically, if you just copy and paste this in your terminal, you'll have this whole repository created in the file explorer. This particular folder, this particular folder, we'll be using that for Ansible, to store the Ansible codes that we're going to use. In this, here we're going to store the variables in this .yml file, and then here we'll be using these files to store the configurations, basically, which will be running with the Ansible. Yes. This particular folder that is named app, and it has main.py Python file and config.yml, basically a configuration file for this main.py and requirements.txt to list all the requirements that needs to be installed in that environment. And yes, in this file, we'll be defining a Python code, which will be our cloud function code, and we'll be running that to pull the data out of that YouTube API and stream it in PubSub. So this is the code that we're going to use for that. Right now it is empty, but we'll be pasting the code here. And then we have DAX. This is the Composer Python file that designs the composer, that designs the pipeline that needs to be followed. And then we have Dataflow. Dataflow creates, like I said, it streams a particular process using Apache Beam. In our case, we'll be pulling the data out of PubSub and then process it and store it in BigQuery. This is that, and this is the configuration file for that, and this is the requirement.txt. The list of requirements that we need to install will be listed here in this file. We have infra. This whole infra folder is for Terraform. Like Ansible has its own folder, this is the folder for Terraform, that named infra. Here, envs/dev, it has main.df. In this file, we are going to put in the code which basically defines the modules that are going to run. And the actual modules will be saved in this folder that is named as modules. Here it says it has every single task that we need to do in order to create that particular resource. We're going to create BigQuery resource, Composer resource, IAM, in which we are going to create a service account and grant a few permissions for that. And then we have PubSub and storage. Yes. So yes, this whole infra folder is for Terraform. And then we have ML. This particular .py, pre-trained sentiment.py file is to run the natural language API, which assigns the sentiments for the given comments. That's what this code is going to do. And the Jenkins file to execute the Jenkins whenever we do push to that particular GitHub repository. And the readme.md that we're going to use in the GitHub. And yes, that is the skeleton of our project basically. Now we are done with the step 2. Going into step 3. Enable Cloud Function API. We have to enable all these APIs. Every single API serves its own purpose in our project. This Cloud Function API is used to run the cloud functions that we're going to use when we do the cloud run. Then we have Cloud Resource Manager, Artifact Registry API, Cloud Build API, Event Arc API, Cloud Run, Admin API, Cloud Composer, which used for the Composer, Cloud Natural Language, for the machine learning model that we're going to use, and then Dataflow for the Dataflow, YouTube Data API to pull the comments from YouTube API. Yes, to enable all this, you just need to, let me just copy this, search it in the search bar, and you'll find them. And you need to enable every single one of them in order to run this project. Should say API right next to it. Click on it. You need to enable everything that is listed here. So let me enable them. So after it is enabled, you should no longer be seeing the enable button. That is the confirmation to know it is enabled actually. Let's do that for every single thing. Every single API that is listed. Dataflow API, enable. And for the last one, it is quite different for the YouTube data API. We don't just enable the API, we also take the API key to use that in our cloud function. Need to enable that. And here, after it is enabled, you should click on credentials. Create credentials, API key. I'll just leave all the settings on default. Click on create. We just need the API key. And copy this API key and save it somewhere. I'm going to save it in a notepad so I can use it often. Save it right here. Save YP. Leave it right there. After that, with that, all our APIs are enabled, which means we're done with this step. And the next step is save Terraform files. We have to save all the Terraform files before we run the Terraform actually to create the infrastructure. Okay. Now, let me pull up the Cloud Shell. In the editor, like I said, all the Terraform files are placed in infra folder right here. Firstly, let me get the main.tf. In infra, in dv main.tf, like I said, I can't write all these codes on video and explain them while I write them. Sorry, like I said, I can't write all these codes on the video and explain them while I write them because there are a lot of codes in this project. If I write them, it takes too long. So I'm going to copy paste it and I'm going to explain you every single code and its use. So main.tf, variables, we need variables. We need main.tf variables. Oh, sorry, we don't need these two files, by the way. You will not get that because I'm going to change that command file. Okay, I'm going to delete them right now. Okay, and yes, for the variables, this, let me copy that, paste it, main variables, and then in the modules, BigQuery, we close this, modules, BigQuery, main, copy that, paste it, and for the composer, IAM, then pops up and then storage. If you look closely, there are a few folders that I never use in this project, but there are existed in this GitHub repository, like Cloud Function and Dataflow. They're not actually present in my new repository here. See, the modules only has BigQuery, Composer, IAM, PubSub, and storage, not Dataflow or Cloud Function. I mean, I forgot to remove this from the GitHub because I've done a lot of trial and error before I actually filmed this video. So yes, these two folders are not necessary, but the final repository that I'm going to give you with the link will be the final one. All these extra files and folders will be taken out. And yes, providers. Read that folder, that file too. Save it. With that, I think we copied all the Terraform files that we need. Now I'm going to explain what we just did, right? In this, starting with this. Now, let's start with the modules first. In modules, every single code is a module to create a few resources in that particular thing. For the BigQuery, we're going to create, I think it's 2 resources in BigQuery. We're going to create 2 tables. Firstly, starting with this here. You know what? Let me start with this. Sorry. Let me start with this one first. This main one. Here, we list all the modules that we're going to use and their names. IAM, PubSub, BigQuery, Storage, Composer. All these modules, which we define under the modules. So if you take a look, it has BigQuery, which is here, Composer, which is here, IAM, PubSub, storage, and storage here. So we're going to define all the modules in this one. So this is basically the main Terraform file to execute with. And yes, it basically says the source, where it comes from. It points to the source. So it is stored in modules under IAM folder. And yeah. And then we push these 2 variables into the module. You might wonder where these modules are defined. We define them in the variables.tf. We take a good look at this. So we define the variables here. Variable project ID. By default, it is this one. So whenever you push project ID variable into the module, it can get access to this particular value in that particular module. And yes, we are defining the variables in this one, variables.tf. Yeah, here I need to change the project. We put in our project ID here in the spot of default. So to get the ID, you have to click on that on the top left and copy the ID from there. Now click cancel and paste it here in this spot. And the region is totally up to you. You can choose a region that is closer to you, or if you want to choose a region that has more, facilities, I would recommend US Central. I mean, I'm telling you that particular region because I've already tried to create a few modules, and I had a few problems with other regions, but US Central solved a lot of them. So I would recommend to use US Central if you don't want to use any of your closed regions. So US Central would be a good option. But now I'm going to use Asia South, which is close to me. Yes. And yes, this module, we are passing these two variables into this module. And then we create pub/sub, and this is the source where we save the pub/sub right here. We're going to point that file, and then region, we pass project ID, and then module BigQuery source, and then point to the BigQuery right here. And then we pass the other two variables to it. And the storage, the same thing. We point to storage, two variables. And lastly, we have composer module. We define composer module, and we point the source. We pass project ID and region. And also, we pass name for that particular composer. We can hard code it inside the module, or we can just write it here. That's fine. Or we can add it to the variables as well. Doesn't matter. It's the same thing. But I mean, I just wrote it here. It is not. It doesn't have to be secure or something like that. So yes, I just defined the name right here, and CFSA email equals module.iam.cfsa email. What does this means? This means it is taking this particular email from this particular module. So we define it like this, module.iam, right here, module.iam.cfsa email. So which means it is taking this email from this particular module, which will be created when running that module, and referencing it to this key and pushing it into this module, composer, because we're going to use this email in the composer. That's why. Now, getting into our first module, which is IAM. Oh, let me open that. Here, you might see a large code written in this IAM module, but most of it is just same with a different role assigned. Here, when we push the variable from the main code, when we push the variables into the module using project ID region, we also need to define them when we run that particular module at the top right here. So we define the variables that we will be using, project ID and region, or else they won't work. So we are defining the variables again here at the top, and then the resource, we're defining the resource, Google service account. So we're creating a service account that we're going to use. We're not using our personal account in this project. So to make it closely replicable to an actual enterprise grade project, we're going to create a service account that has all the permissions that needed to run this whole project. So we're going to create a service account. This is the ID for this particular resource, and the account ID will be cloud FNSA. SA stands for service account, cloud function, cloud FN, cloud function. Display name, cloud function service account, project. So this service account is assigned to this particular project. And yes, this block is to create the account, and all the rest of the blocks starts from here to the end. All these are to assign roles to that particular service account. If you take a look at this particular code block, it says resource Google project IAM member. IAM stands for identity and access management. Yes, Google project IAM member, CFSA BigQuery admin. This can be anything. This is just to identify this particular code block, this particular resource. And then this is the project, and the role that we're going to assign is BigQuery.admin. So he will be the admin for that BigQuery. He will get the privileges of admin of a BigQuery. And the member will be service account, Google service account.cfsa email, which is this. We just created Google service account.sfsa.email. So this will be the service account, and this service account get this particular role assigned to it. And that's the same thing happened here. So this is for the BigQuery data editor. This is for BigQuery job user. This is for BigQuery.user. Cloud Function Admin, Cloud Function Invoker, a lot of them. So we need all these permissions granted to this particular service account in order to run these codes in that project. We'll be using every single row in upcoming steps. We need all of them. This is, so this cloud function is for running the cloud function invoker, cloud function worker to create a worker in the cloud function, data flow, and so on. And yes, we're done with IAM. And the next one is PubSub. Set to PubSub module. And this creates a PubSub. Like I said, the variable should be defined at the top of that particular module in order to work with them inside the module. So they are defined here. The resource is getting created here. Resource Google PubSub topic, which creates a topic. This is just a unique identifier for this resource. The name is YT comments topic. So this is creating a PubSub topic, basically, YT comments topic. We'll be seeing more about it later. Okay. Yes, we'll be creating a topic here for PubSub and assign to this particular project. And output, if you want to use this particular name in any of the resources inside the Terraform, we just need to assign out, not just in the Terraform. Like basically, if you want to use it outside this particular block, if you want to use the PubSub name outside, you just need to define it at the end. If you don't define it, you just need to hard code the PubSub name. Either way, it works. Okay, that is that. And our next resource is BigQuery. BigQuery, we will be creating one dataset in BigQuery and two tables inside that dataset. Like any other module, we will be defining the variables first at the top. Okay, and then we'll be defining the dataset of the BigQuery, which is resource Google BigQuery dataset, YT dataset. This is the ID, this is the prompt, Google BigQuery dataset, and the dataset ID is YouTube comments. We'll be creating the dataset with the name YouTube comments, assigned to this project, assigned to this location, which is Asia South 1 in my case. Yes. Next one. We created the dataset. Now we create the table inside the dataset. We will be using two tables in that particular dataset. One is named as comments and the other one is named as sentiments. We'll use comments to save the cleaned comments. The data, basically the data coming after the data processing using the Dataflow plus like I said here, the cleaned data that is coming from the data processing, which is done by Dataflow plus Apache Beam. So these cleaned data will be stored in this particular table inside the dataset. And then this data will be pulled out and then assign the sentiment magnitude at the end of every single row. This data with the sentiment is saved later in the same dataset, but in a different table named sentiment. In the same dataset, but different table. That's why we create two tables in one particular dataset. Okay, let's take a look at this. Resource, Google BigQuery table. Like I said, we're going to create a table. This is a unique identifier for this particular code block. Dataset ID. We'll be naming it Google BigQuery dataset.yt dataset.dataset ID. Table ID will be comments. Project, the variable, will be assigned to that particular project. Schema. And then this schema has this definition. It has 3 columns. The name of first column is comment ID and the name of second column is comment text. comment ID is a unique ID for every single comment, and comment text is the actual comment, and published at is the time that the comment is actually published. So comment ID is of type string, and the comment text is string published at is timestamp, and then the mode is required. Everything should be required. So that is that. So we assign the schema to that particular table, and here we're going to create another table with the table name sentiment, like I said, assigned to this project, and the schema. Here we'll be having 4 columns. One is named comment ID, unique ID, comment text, the actual comment, and then sentiment score, which ranges from -1, -1 to +1. So if any comment has score that is greater than 0 is a positive comment, and if it is the other way around, it is a negative comment. So that is how it is scored using sentiment score and sentiment magnitude. These two will be added, and they will be in decimal values. So we say float, and these comment ID and text are strings. Mode required. It can be nullable here because some comments might not have any sentiment score, so it can be nullable. Yes, this is with the BigQuery. Now, done with these 3. Now with the storage, let's head to the storage. Here we have, like any other, we define the variables, and then resource. We create buckets, and we name it YT raw comments mine hyphen, and this one represents pulling the variable in. So it is basically saying to create a bucket named, start with this, and at the end it should be adding the project ID. Oh, my bad. So we're going to add the project ID at the end of the bucket name, and it is assigned to this particular location, which in my case is Asia South, and force destroy. This is, you don't need to run this, you don't need to include it, but if you want to, you can. Uniform bucket level access true. So force destroy is nothing but, if you want to destroy a bucket from a command line, it will ask you, it will prompt yes or no. So if you want to delete it without any confirmation, you just say force destroy equals true. And uniform bucket level access true. And we have another bucket, resource Google storage bucket, CF bucket is a unique identifier, like I said, and name YT CF source, and at the end the project ID. So we're creating 2 buckets assigned to the same region, same location, but with the different names. And every name has project ID attached at the end. And yes, that is that. We're done with the storage. Now with the composer. Head to the composer, main. Here we are going to use 3 variables. So we defined 3 variables. So we defined 3 variables. Now we defined 4 variables actually. We don't need 4 variables. Let me see. Name project ID CF, name project ID CF. We don't need the region to be defined here, but I'll leave it, that doesn't matter. Okay, so we define these 3 variables. Then resource, Google Composer environment. We're going to create a composer. This is the ID, unique ID. Name, which we defined. So it will be named as YT pipeline composer. And then project, region. Here, I did this because, like I said, US Central offers a lot broader services for free, even for the free trial accounts. So if you face any problem creating any particular resource in GCP, just try with US Central, because I think personally that solved many of my problems. So I did this. I mean, when I did the trial and error on this project, on the first time the composer got created with the South Asia, but after that it didn't. So I used US Central and now it is working. So I just changed this region to US Central because it is working. Yes. You can try with a lot of variety of regions if any resource is not get created. And for the configurations, the image version, this is the composer version and this is the airflow version. Composer will be using airflow to run the particular orchestrated pipeline. Composer itself doesn't have anything, so it uses airflow to run that. Environment status, these are all extra options that we're going to choose. Even if we create a composer using the UI, you'll do this. You will choose these options. So while we write the code, we just write it like this. I think I did a very bad job explaining it. So let me show you how it works. So if you want to create a composer, go here on the UI. You basically hit create composer 3 or composer 2, whatever it is. And here we put in the name, which we already defined in this code. And we put in the location, which we defined as well. And the project is assigned automatically. We don't need to put in the project here. And the service account, we need to select a service account, and that is starred, that is asterisk, which means it is mandatory to select a service account. And for that reason, we also assign a service account here. And that is why it has an extra variable CFSA email, which will be creating using this module in IAM. We'll be also assigning to this composer as a service account right here. Yes, that is that. And then resilience mode standard. So we're just basically selecting this. Instead of selecting that on UI, we are just coding it right here in Terraform. That's what we are doing. And environment style, small. Here, instead of choosing small in this environment resources, we're just writing it, we're just coding it in Terraform. That is what's happening. Okay. I think now we are clear. We have everything that we need in this Terraform. When we run this Terraform, all the modules will be created automatically. Let me just close this. We don't need it. Great. Okay, to run this Terraform, all these module files, let me head to Open Terminal. Because we are using Cloud Shell on GCP, GCP by default comes with Terraform installed in the environment. So you don't need to install Terraform again. All we need to do is, I forgot to follow the steps that I wrote. I'm just doing everything by myself. Okay. These are the steps that I wrote. So, okay, save Terraform files, which we already did just now. And our next step would be Terraform init. We need to initialize Terraform first. Okay, before initializing, let me add another step here. What we also need to do is, we need to run this command, cd infra envs dev cd infra slash envs slash dev. We need to run this command because we need to go into that particular folder to run that Terraform code. I'm going to add that step here. Right, that should do. Yes. So we need to run this command. Let me run that. Now we are inside this path, which means in the file explorer, we are basically here. Now we can run the main.tf from here. Let me make sure the variables are correct with the new project ID. Now head back to terminal and run Terraform init, which means we're initializing the Terraform. Should say Terraform has been successfully initialized, and then we do validate. Terraform validate basically means validating the Terraform and it says if there is any syntax error. In my case, I have a syntax error right here. It says the argument named region is not expected here, which means, okay, I see what happened. I haven't defined the variable region at the top. I thought I never used it inside, but I did use it. So I'm going to variable region quotes and flower brackets. That's it. Now let me run that again. Like I said, it checks for the syntax errors, the basic errors. Okay, now I got a few more errors here. Okay. Well, I'm getting these errors, but I make sure I'll post the files without any errors into the GitHub, so you don't get these errors that I'm getting now, because I will be fixing them right now. So first error, if you're interested to debug these errors, you can just still watch here, but if you don't want to, you can just forward it to where I already ran the Terraform. So the first error says reference, invalid reference, US Central. Here, the problem is this. This should be inside the quotes because it should be a string, but I haven't put the quotes here. It should be inside the double quotes. This should be fine. And the other error that I got is Google project current has not been declared. Well, I ran this with the Cloud Shell before and it worked, but in this it doesn't work. So to fix that, let me go back to IAM. And this is the account that is triggering the error, this one. So every other role assignments here is for this account, But for this one, this is a separate account which has the account name, account ID with the project number. So it is different. So we need to assign this role for this particular service account in order to run the composer. That's why I included this here. So the problem is here. To fix this, there are a few ways. Firstly, let me just get the project number, it says. So the project number here is I think you can get that at the welcome screen. No, at the right here. So yeah, this is the project number. Okay. We can just put it right here, just like this. You can just raw code it like this, or we can just assign it to a variable and define it here, and then we can call the variable inside this. Either way it works. Or let me just add, let me just define the project. So this particular block defines the project. So it says we are running in this particular project using that project ID. So now this might be able to, hold on. Yeah, so this might be able to now retrieve the project number here because we define the project ID at the top. This. So this should be also fixed. This should be fixed too. Now let's run that again. Run Terraform validate. So now it is success. Terraform plan. It's basically crafting a plan, and then in the next command we do Terraform apply. Then we apply the plan that is crafted. Or you can just skip these two steps with just one step. You can run this command instead of these two. Either way it works. But let's go with the traditional way. We're going to plan it. There you go. And we're facing another error. It says something with the composer. Okay, so here the resilience should be one of these two options. Should be standard resilience or high resilience. But I think we have a typo. Let's check. So here, so it says resilience mode standard, which is not good. So we're going to copy this. Let me paste it here. Standard resilience. Now plan it again. Now run the Terraform plan again. That is fixed. After that, run Terraform apply. You see every resource is creating, and they started creating parallelly, and any creation is completed. If any creation is completed, it says creation complete after 2 seconds. These are, you check the logs, and it says CF source body project. That is the project. Let me show you. So this particular log says the bucket is created, and the name of the bucket is ytcf source yt comments. And like I said, this whole part will be our project ID, and this is a static part of the name that we defined. And yes, it says creation complete. And we got another error that says it is with the composer. Let me fix that. Assuming the cause of this error is basically the time delay of assigning these roles to that service account that we just created. Because we just ran the Terraform, and it's been a few seconds since we assigned the roles to that service account that we created. And that's why it says the roles are missing. Like right here it says roles composer worker or composer or equivalent set. Because we already assigned this role composer worker, if you take a look at our IAM code, and even if you take a look at the IAM right here in the UI, on the side pane, IAM admin, this is the service account that we just created, and it has composer worker role already assigned, which means this should be fine. But we are getting this error because it is not, it shows on the UI, but it is not actually assigned. It takes the Google Cloud Platform take few seconds to actually give the privileges, to activate these privileges to that particular account. So we just need to wait a couple minutes before we run this Terraform again. So I'm going to wait. Okay, it's been a few minutes now. I'm going to run that again and see if that works. And now, if you get any error while you run the apply, you just need to run the Terraform plan again, and then you need to run the apply, or else it won't work. You need to plan it first and then you have to run this, or you can just run this command instead. That's the same. That's basically the same thing. Yes, we just need composer to be created. By the way, you won't get any of these errors while you run these codes, except for maybe the region errors or the time delay errors like this. You won't get any other, because I am fixing every error for you on camera, all these minute errors that I'm getting. So you would know if any error gets to you. If you encounter any errors, you can know how to fix it. If you, basically, if you get an error, look for the line that says something familiar to you. Like in this case, the error says this one. You are familiar to it because you created that particular service account. So you can just look up for this error. It says cloud function SA YT comments, which means we created this service account right now. Yes. And is expected to have at least one role, like roles composer.worker or an equivalent set, which means it should at least have role composer.worker or anything equivalent to that or higher than that, like admin or something like that. And I checked it on the portal and it says composer worker is already existed, which means then it is easier to us to debug. It is basically the time delay that we got. We have to wait a few minutes after we assign these roles in order for those roles to be actively working. And yes, now it is working, but composer takes a while to get created. It mostly takes like 20 to 30 minutes to get created. So just let it run in the background. If you're not going to bother about this, it will be running. But for now, we'll go ahead with the other step. Save.gitignore. I don't think we need to run this because, tell you why. In the tree.txt, I think I already included, here. I already included that. So you should be able to find this file. So you don't need to create it, you just need to save it. Oh yeah, save it. You just need to save the .gitignore. Okay, now switch to editor. By default, you will not be able to see .gitignore file in the file explorer. You need to click on the view and then click on toggle hidden files. .gitignore by default gets hidden, so you need to toggle hidden files. That is where you find .gitignore. Now copy the gitignore. If you're basically saying basically doing this because we don't want to push these files into GitHub. Save it. Yes. We don't want to push any files, any Terraform files into the GitHub. Along with that, we don't want to push this file. We don't have this file yet, but we will be getting this file in the future steps. I'm going to show you when we will be getting that. And I think I also have to add some more files here, which includes this one, Terraform TF state, Terraform TF plan. We don't need those two files too. And I think, yeah, whatever files you don't want to push that into GitHub, you can just mention it here and it won't do that. You say TF plan. Now this is ignored when you push the repository into GitHub. And then you say Terraform .tf state. This will also be ignored. And I think there is one more file that I need to ignore. Terraform state. Yeah, there will be this file. This should also be ignored. It is not yet created in our repository, but it will be created after the Terraform is executed. But right now, it is still under process. Yes, so it is still under process. So that file is not created yet, but we have to include that in git ignore to avoid it to be pushed into that. And then we have with the Terraform TF state, Terraform TF state backup. I don't know about that file, but let me add that too. No, it doesn't make sense. I don't need to add this, I guess. Yeah, this is fine. Because we already added .terraform /. This will avoid any file that starts with .terraform, .terraform.log, HCL, all of them. So we don't need to worry about that. Yes, we added these files. Now we're going to push our repository into GitHub. Because we can't rely on this particular Cloud Shell, you might lose all your data. And you also have to have a look on this session information right here. You have to click on this and keep an eye on this quota. You only get 50 hours per week to use this shell. After you exhaust these 50 hours, you lost all the data. You lose all the data temporarily, not permanently though. You lose all the data. You lose access to all the files and folders that you created in this Cloud Shell until the quota will be resetted. And it will be resetted at this particular time, like it says. So if you lose the data, you cannot access it until the quota resets. So to be secure with that, you need to push all the repositories, all the changes that you do into the GitHub. Okay, I'll show you how to do that right now. To do that, first, sign in into your GitHub. And let me go to the main page. Click on create repository. Where is it? Click on new, create a repository, name it YT comments GCP. Yes, just hit create repository. Now we have an empty repository. Yes. Now we'll go back here. Here, open terminal. Because there is a process already running in this terminal, I'm going to use another terminal, so that we need to click on this plus button. Now we'll get a fresh terminal. Here, cd yt GCP. Inside, now we need to initialize Git. Let me open the steps. We need to initialize Git first. Before pushing into GitHub, we need to initialize it first. Let me initialize that. Initialized empty Git repository. That's the confirmation that Git is initialized. Now we should be able to see .git. You may not see because that is one of the hidden files, I guess. I cannot find it, but that's fine. Unless it works. Unless it works, we don't need to bother about that file. Okay, it says initialized empty Git repository. That's what we need. And then the next step is git add dot. Git add dot basically adds every change that you've done, including creating all the folders and files and the codes that you run. Everything will be changed. Git add, and then we do git commit -m to put in a commit message. Here I'm going to say initialize or initial skeleton. I'm going to say initial skeleton. Run it. 29 files changed and 319 insertions. Yes. Now we're going to run git branch main. Need to make sure we're in the main branch. For the first time, we need to add the origin. Now we can't just run it. Let me edit this. So next to the origin, here we need to insert our repo link. So, yes, this is our repo link. We need to copy that, the whole link, and then git remote add origin, and then paste your git repo link, and at the end add .git. Now this should work. The origin is specified, and after that we need to do git push. Now it asks for username. You can get the username from here. You need to paste your username. Paste mine. And for the password, you might think it's the usual password of your GitHub, but no. You cannot use your actual password. All you need to do is go to settings in the profile, and here scroll down. Should be the password and authentication. No. I think it is SSH keys. Yeah, you need to click on that. New SSH key. I forgot. Let me check. Okay. Here, we don't need to use the SSH key. We need to go with the tokens. We need to go to developer settings. Click on personal access tokens. Click on find gained access. Find gained access. Generate new token. You need to put in your password. I'm going to put mine. I'm going to pause the video. After that, you'll land on this page. You need to name your token. I'm going to say YT access. Right? I'm going to say YT project. That's fine. Expiration shows all repositories, and here add permission. I think I listed the permission here. The permission should be git contents, read and write. Here, look for contents. Select contents. Should be read and write. Generate token. Click on generate token and copy this token. Paste it next to the YouTube token that you got. Okay. That's it. Now head back to the terminal. Paste the token here. Even if you paste your token, you will not see it. It won't show you, but don't worry, just hit enter. Now everything will be pushed into your repository. If you see this message, it says total and reused. Now if we go to our repository, we should be able to find all the files that we created here in the repository. Any change that we make, if you want to save it, we can't save it. We cannot rely on the file manager, the Cloud Shell. We just need to push it into GitHub repository. Now, if you can see it is already past 17 minutes since I started the composer creation, and it is still running. It takes time, like I said. Yes. Heading to the next step. Now, before doing step 10, I'm going to do step 11. Save app files and Ansible. We're going to save all the files that are related to apps. Let me just close all these windows. I'm going to fill all the files in the apps. Firstly, the configuration. Go back to GitHub repository and open the repository that I gave you, and you will find it there. Config.yml here. Paste it here, and channel ID YouTube API key. This is my old project's API key, but this won't work now. Now I want my new one, which is this. I'm going to copy the YouTube API key and paste it here. Max results can be anything, that's up to you, and pub sub topic should be YT comments topic, because that's the topic that we created using the Terraform. In the channel ID here, you can specify any channel ID, but this channel ID is for my YouTube channel. But if you want to use a different YouTube channel, you can do that too. Let me show you how you can do that. You can get any channel's ID by just going to YouTube. What happened to my browser? Just going to YouTube. Oh, I am not signed in right now, but I'll show you this. Let me sign in into YouTube first. Go to any channel homepage, any channel that you want to use, and then right click, go to inspect. Is that inspect? No. I don't think it's inspect. Open channel, right click, view page source. Right click and click on view page source. And here, next you want to find channel ID. I'm going to copy that. Click on here, find on page, paste it here. You'll be able to see right here, channel ID equals to, and now you need to copy that particular string. Let's go to the next one. Okay, I need to copy this. How we can copy that? I don't need this whole thing, but it is not letting me to copy that particular part, so I'm going to copy everything from here to here. I'm going to paste it somewhere here. And I don't think we need the whole thing. Yeah, we do need the whole thing. Yes, that's correct. Now paste it in channel ID. That's it. That's how you can find any channel's ID. You just need to go right click, view page source, and click on Control F. That's it. You just need to click on Control F, and this will pop up, and here you need to type in channel underscore ID, and you'll find this on any of the line. I think it's on the 12th find. You'll find it on 12th find, and copy that ID and paste it in the code, and that's how we can use it. And yes, that's the channel ID, and we already pasted our YouTube API key. And yes, everything's fine. Now let's go to main.py. Copy this whole thing, paste it here, and requirements, same thing, copy, paste. And also Ansible, let's do the Ansible too. Copy all the variables, paste it here, and here we need to change the project ID with your actual project ID. And like I said, the region is up to you. You can do anything, and you also need to paste the project ID here in the service account. And also here But here you just need to paste the end of it, just the numbers. That's it. Save it. And we also need to save deploy CF. Copy that. Paste it. Save. Nothing to change here because we are using the variables from all.yml. So we don't need to change anything from here. So let's understand the code, the cloud function that we're going to run, right? Firstly, we're importing the modules that we need. We import YML. We import YML to refer to the configurations, which is .yml file. And then we import OS to refer to the environment variables. And then we import JSON to get access to the JSON functions like JSON loads, JSON dumps. And from google.cloud, import pubsub. We need this to access pubsub. We need that module. And then from Google client.discovery build. And then Flask request. These to raise the HTTP requests. And here for this, we need to load the config.yml to get the configurations, the variables. We use that. And here's the module that we defined imported at the beginning. And then we initialize the client. YouTube equals YouTube version 3 developer key configuration YouTube API key. The API key that we got from the Google GCP API key, GCP YouTube API key. And then publisher, pubsub v1 publisher client. Pubsub stands for publisher/subscriber, just if you don't know. Publisher is the one who publishes the data, who sends the data. And subscriber is the one who gets access to the data, who pulls out the data that's sent by the publisher. Now we are publishing the data taken from YouTube API. The comments that we take from YouTube API, we publish that in pubsub. So this act like a publisher. All right, and this is the module that we imported at the beginning right here. Yes. Project ID os.environment.get. OS, remember we imported OS because it gets access to any variable, any environment variable. When I say environment variable, this GCP project is defined when we run the Ansible, this code. Let me show you. In this Ansible code, we are going to define this environment variable right here. See, set an env variable. So it is setting the environment variable right here. So it can be used, this variable can be used all around the environment, anywhere, anytime. That is what we are using here. And just in case if this doesn't work, it takes this. We hard code the project ID just in case. All right. So let me just edit that as well. Right here. It doesn't matter because most of the time it takes the environment from this environment or variable. But if that doesn't work, and then it accesses this one, the hard-coded one. And the topic name, config pubsub topic, which is this one, pubsub topic. And we do some prints for debugging, so it makes it easier for us to debug. Init using project ID, using topic, full topic path. So it confirms all of these parameters are in the place. So it prints it. This is the main function. Like I said, we use request. We imported the request module at the beginning right here in order to pull the request for HTTPS. Print YouTube comments ingested started. So this makes sure, this lets us make sure that the actual process is started when we look up the logs when we run this cloud function. I'm going to show you how to check on the logs. So if any error occurs, you can go through the logs and fix it easier. We do try and expect here. So firstly, it tries this one. If that doesn't execute, it goes to this except. So if anything in the try doesn't execute, it just runs this and says error failed to fetch YouTube comments, all right? And returns error fetching comments. But what is actually in try will be executed first. If that doesn't work, then it goes to exception. Here it says request youtube.comment threads.list. It takes up the list of the YouTube comments and parts of snippet, all thread related to channel ID, configure channel ID. So it filters just this channel ID. So it just takes out the comments that are related to the channel ID that we given. Then max results will be max results. In our case, we defined it as 50. So it takes 50 maximum of 50 comments from the channel. Response equals request underscore youtube.execute. So it executes the request. That executes the request, and then it prints out retrieved length of the response comments from YouTube API. This is the dynamic f strings that we use to print this particular particular dynamic string. We're going to use f strings for that. We define a variable named published count, and we assign it 0, nothing basically. Not nothing, we assign 0. And we start a loop for item in response.get of items, comma, a list. So items is where we have all the comments. So it gets one response at a time, and it pulls out comment text, the actual comment, and it also pulls out the comment ID using this, and message JSON dumps. Well, when we retrieve the data from the YouTube API, basically the data comes from through the response. Then we take out the comment text, the actual comment and the ID, and we combine both of them using assigning this as an ID for the comment, and this, no, I'm so sorry. So yeah, it takes ID, comment ID and comment text, and it changes the name of the ID, comment ID to ID, and comment text to just comment. So these two will be the column names of our new data file. And then it dumps the particular row, the particular message into JSON. JSON.dumpsof method is used to convert a dictionary into a JSON file. That is what's happening here. We're going to convert this particular dictionary into JSON. And then print publish sending comment, and prints the comment ID to make sure to make the debugging easier. We use these print commands in the middle of these executions just to make sure how far the code is executing and when it is failing. We will know that. So we are using try and expect and all these print commands to make it easier for us to debug if in case we encounter any error in future. Yes. So it prints here, publish. This is all the static part. Like I said, we use f strings. This is all the static part of the print, and this is the dynamic part. This prints the comment ID less than 10. So it prints the top 10 comment IDs. This is the list function. I think it is called list comprehend. No. We'll call it list function. We use this to print the top 10 of that particular list. So it prints the comment IDs of top 10 comments. I mean, no, I don't say top 10. When I say top 10, I mean the index numbers that is assigned for that particular object in that list. And yes, future equals publisher.publish topic path message json.encode. We need to encode before we stream. So we're going to use encoding UTF-8 to encode the message so that we can publish that to PubSub. Future.result. Published count +1. So it counts how many messages that we published. Except exception. So if anything goes wrong in this try block, then this exception executes and say error failed to publish comment. And if everything goes fine, then it prints success published count, which is here, which an incremental variable which prints the amount of comments that are published. So if it is 40, it says published 40 comments to PubSub topic. That's what it says. Topic path. And return PubSub count. And yes. That is it with the main.py. This is our cloud function that we are going to run to get the comments from the YouTube API to stream on PubSub. These are the requirements. It has Google Cloud PubSub, API Python client, PyYAML. We need to install these requirements first to run that main.py. So we list all these requirements in requirements.txt. And now for the deployment part, here we say run that on localhost, tasks, zip the cloud function source. We need to zip it before we execute it in Cloud Run. So we're going to zip everything. So everything in this path. So which means all these three folders, these three files. So everything in app folder, all these three files will be zipped into one zip file, right? And saved in this destination as yt ingestion.zip will be named as that, and format will be zip file. And this zip right now is in the local folder, File Explorer right here. But again, next it will be uploaded to GCS bucket that we created. To do that, it says gcutil cp yt ingestion zip Google storage ytcf source project yt ingestion zip. So it saves into this bucket. It saves this zip file into this bucket and then deploy cloud function. It deploys the cloud function. Here it is defining the cloud function first. Yt ingestion function, region, the region I specified in the all.yml, which is Asia South for me. And then runtime will be Python 3.10 and trigger will be HTTP because I think it cannot be triggered by anything. So we use HTTP to trigger. Allow unauthorized service a source. So it says the source where to get the zip file from. So this is the source that it gets the zip file from. The file which has all the necessities to run the main.py. And the entry point is main. So it says the main file as the entry point, and service account. It runs with this service account and set env variables. Like I said, the environment variables we can use anywhere in the environment. And then quit. That's it. I think we're all set. Yep. What is our next step? Save all the files in Ansible, and then we need to run sudo apt update, and then we need to install Ansible first. Terraform is pre-installed in the Cloud Shell of GCP, but not Ansible. We need to install the Ansible again. I mean, Ansible whenever we run the Ansible code. Okay. Let's open the terminal. Then let me check on the composer. Yes. So it took me 21 minutes for the composer to get created. So if you go back to composer, you will be able to find the composer is active. The state should be active. It should be just show you the tick mark, which confirms it is active. Okay, now it is created. So I am going to close this terminal. We just need one terminal now. Okay, we're in this one right now. From the root of the project repository, let me install Ansible first on the shell. Run that command first and then run this command. After that, we need to run this. In this command, we are referring to the deploy cf.yml, which is our Ansible deployment file. Ansible playbook, Ansible inventory, Ansible /playbook /deploy cf. That is where the path for that deployment file. Just takes a couple seconds to get installed. Yep, that is done. After installing Ansible, we need to run the deployment code, paste it, hit enter. So it shows the task that it is performing. Firstly, it is gathering the facts, and then, which means it is gathering the facts, and then it is zipping the cloud function, which is this one. So it is zipped. The cloud function is now zipped. It says changed. Now it says upload zip to GCS bucket, and it is also executed. Now it is deploying the cloud function. This might take a few seconds, but when that is in progress, let's check whether the zip is actually uploaded to the GCS bucket. On the left pane, go to cloud storage, click on buckets, and the bucket that we specified here is YT raw comments. So it is this one. In that bucket, we should be able to, no, my bad. No. We uploaded that zip file into this bucket, remember? We specified it in the deploy CF. So it is YT-CF source, starts with YT-CF source and our project ID. YT-CF source, YT comments, and this is my project ID. It should be here. So we can find that zip file here. Start with the deployment. Let me just, I don't need to pause it. I just wanted to pause it and play it again after it is executed, but never mind. Now it is executed. The cloud function is successfully deployed, which means we should be able to go search for cloud run functions. And you should be able to see YT ingestion function right here. And if we switch to source, we will find our 3 files that we created inside the app that are zipped and pushed into the cloud function here. So these are main, and these are config, and these are requirements. And yes. Okay, now we have that here. Well, I think I can test it. Click on test. Here, click on test in Cloud Shell. And when you extend this Cloud Shell, you should be able to find these commands pasted. Run it. Now it says comments push to PubSub, and it says 49 messages. Well, the max limit we defined is 50, but the YouTube channel we are using here is my YouTube channel, which only has 49 messages, so it just shows 49 messages. Okay. Which means we should be able to go to PubSub. We go to PubSub and we confirm the messages are in the PubSub actually. So this is the topic that we created. A PubSub topic is like a stream where messages can fly around. And to access these messages that are in the topic, we need a subscriber to be created. Like I said, a publisher is the one who pushes the data, and the subscriber is the one who pulls the data out. We need someone to pull the data out, which means we need a subscription. So let's just create a temporary subscription. Say, I'm going to name it temp, and it should be pull. And yes, let me create that. Hit create. Should take a few seconds. Successfully created. Now switch to messages. Hit pull. Now this pulls the messages that are streaming in the PubHub. This is basically like a mailbox where we can receive the mails, but we need to pull them. Well, it says no messages found yet, but I don't think that's correct. Let's go to the Cloud Run function again. Let's run this again after we create that subscriber. Hit the test in Cloud Shell. Oh, it's disconnected. Test in Cloud Shell. I will trigger that again. Okay, comments push to PubSub, 14 messages, 49 messages. Let's pull the messages. There you go. So you have to run that again after you create the subscriber. Well, we got all the comments. Says, so it is the list of the comments with a unique ID for everything, and deadline exceeded, publish time, it has everything. Okay. Now we're done with the cloud function. The cloud function is running well. Well, this is just doing a batch, retrieving the batch of batch of comments every single time, but we will be orchestrating this so that it runs on schedule, like once every hour. So we're going to orchestrate it using composer later in the video. For now, we have the cloud function, which means it's the right time to go to the next step, which is to create the data flow. Now, we have the data streaming in PubSub. Now we need to pull the data out of the PubSub, clean it, and then push the cleaned data into the comments, the table named comments in the BigQuery under the dataset named YT comments, which means BigQuery right here. We need to push the data. We need to pull the data out of the PubSub and clean the data, and then push that into this table, comments table. To do that, we're going to create data flow with Apache Beam in it. Okay, let's head to that. Firstly, our next step would be to save the data flow files and the Ansible files. For the data flow, we have 4 files. Firstly, config.yml. Let's get that. All this data flow, config.yml. Okay, I don't know about that. I think I need to re-log in to the Git. Yeah, I need to restart the GitHub. Okay, we're back again. Go to the repository. Don't get confused, by the way. I added test underscore in this repository because I'm using this for temporary. But the repository I'm going to give you will be named as YT comments GCP, not test. Okay, now data flow, config. Okay, getting a weird error here. Let me do that. Now it is working. I think it's just the server, the GitHub server. Let's copy this into actual files and replace the project ID. Same with the bucket. Place the project ID in the bucket. And the rest will be the same. Same for the pipeline. Copy that. Paste it. I don't think I need to fill anything here, but we'll see. No, I don't think I need to change anything. All right. The requirements. Copy. Paste. Setup. Paste. And also the Ansible deploy data flow. Need that one too. Copy that file as well. Paste it. Yep. Now let's take a look at the codes that we have. Obviously, these are the variables that we are configuring. And here, we're going to import Apache Beam. Like I said, we're going to do the data processing with Beam. Apache Beam, and these are all for the Apache Beam. And here, we import JSON. We import RE for cleaning the data. And datetime to use the datetime functions, and import YML so that we can get the configurations where we can get the configurations.yaml file. Then we load the configuration file. We assign the variables with the values from the configuration file. We predefine them here. Then we open a class, clean command, beam DOFN. Beam.dofn means stands for beam do function. So it is basically saying beam to do the function. Dev process self element JSON.loads. Like I said, JSON.dumps off is the method that is used to convert the dictionary into JSON file, and JSON.loads off is used to convert the JSON file into dictionary. Now we are reconverting the JSON file into dictionary here. So now we have a dictionary of the JSON file saved in record. And here now we get just the comment from that dictionary, which is the actual comment, just the comment, not the comment ID or anything, just the comment, and assign it to text. And text equals text.lower off. We use this, like this is a Python method to lower any uppercase in that particular string. So if the comment has any uppercases in the string, it lowers it just to make it convenient for the natural language model to process that. So this is cleaning basically. So we are going to convert every uppercase into lowercase, and then text equals RE. Like I said, RE is used to clean the data, and re.sub of http/s. So this is where we take out any links that are posted in the comments, if there is any. So the links will be cleaned in this line, and then text equals re.sub of a to z/s. Here, so we are cleaning out any symbols except, so we are using this cap here. So which means we are saying anything other than A to Z and spaces should only be present in the given comment. So anything other than that, like symbols or using the commas, the full stops, everything should be taken out. Only the alphabets, which are lowercase, and the spaces should be present in the comment. That is what it does. After that, it yields everything together again. It says comment ID record dot get ID, and comment text published at. Published at, like I said, the module that we imported here, date time, will be used to get the present time, which is in ISO format. We use UTC now to get the present time, and the format is ISO format. Def RGB equals none option. These are the options that we're going to define before defining the pipeline. And here, project equals project ID. The project ID is defined at the beginning, and then region, US Central. Like I said, US Central is far better than using any other region, in my opinion, because it offers a lot wider features than the other regions. So I'm going to use US Central for the Dataflow runner, Dataflow runner, temp and storage location. So temporary location is this bucket, the bucket we specified in YML. So the data stores here temporarily while the process is going on. The data processing is going on. This is the staging location. This is also the bucket for the staging. Later, wait, there is another option here. Options view as standard options streaming equals true. So it makes the data flow streaming. You don't need to trigger it anytime you want to get the data. You don't need to trigger it. It is like a live stream. Any data that comes into PubSub will be clean and stored into the comments live. So it just streams. You don't need to trigger it. That is what we're defining here. And then we have beam.pipeline. Right now, if you take a look at this, right now the data is stored in this bucket, the staging location of the bucket. And now beam.pipeline, read from PubSub. This reads the data from PubSub. So this reads the data from PubSub. And then clean text, beam.hardDo clean comment, which we defined here, right here, the class clean comment. And so it executes that to clean the comment. And write to BigQuery. Now, the data in the bucket will be taken out and written to the BigQuery. And that is in this project ID, this BigQuery dataset, BigQuery table, which we already defined in the YML. The table is comments and BQ dataset is YouTube comments. Write disposition, BigQuery disposition. If name equals run, if name equals main, run. It basically checks if the file is running in the main function, and if so, it runs. Yes, this is basically it. We have that. These are the requirements that needs to be installed in that environment before running this pipeline. This is a setup that makes sure these requirements are installed. So this file makes sure if the requirements are installed, and it also specifies the entry point. Now we are ready with the data flow. Let's run the data flow. Run it. Our next step will be to run this command. Paste it. One more time, let me make sure I configured everything correctly. Put in our project ID and the project ID at the bucket. Everything's fine. Yes. Now let's run this. Oh, I messed up something. Let me paste it again. Yep. Now, oh, I forgot to explain the deploy, the Ansible code. So the Ansible code runs on the local host, and the tasks are to package Dataflow job. Command Python 3. So this setup.py runs in Python 3 environment, and yes, it makes sure the requirements are installed. And then it has install Python dependencies into the environment. So it requirements.txt, executable pip3, the same thing. And then upload pipeline to GCS. The pipeline will be uploaded to this bucket that starts with YT, raw comments, and the project ID. So it will be saved. The pipeline will be saved in that location. Then run Dataflow pipeline. Well, here, this task is already completed. Upload pipeline to GCS. Now we should be able to find that in the cloud storage buckets. I think it is YT raw comments right here. Pipeline.py. In the staging, if you remember, while the data is processing, we store the data in staging. So this is the staging. This is the pipeline.py we saved into the bucket. We go to Dataflow. Okay, now this is already up and running. The Dataflow is running, but we have to make sure We don't get any errors. To get the logs here, it is right here at the bottom. You click on that. So you can find the logs. If you get any error in the data flow, you can find those logs here, listed here. I think right now it is just initializing. So it needs a few seconds to initialize. So let me give it a minute. And by the way, this command will never end because the data flow will never end. The operation will never end, right? It is a stream. So this will never end right here. But the way you conform it is running is to open the data flow and see it right here. See it in the UI. In my case, it is created, but I'm checking on the logs and see if the data is actually getting cleaned. There will be a few charts popped up here. Now, right now it says no data is available. If it gets data, you can see it right here. So it creates three blocks of data. I mean, 3 blocks of tasks. So we basically created a job with 3 tasks. The first one is to read from PubSub, and the second one is to clean text, and then the third one is to write to BigQuery. Okay, you know what? Let me run the cloud run function again because we haven't scheduled it. We haven't used any trigger to trigger it. So we have to trigger it manually. Oh, I think I can trigger it from here because the terminal is already open here. Click on test in Cloud Shell. Now, before that, we need to click Control C to stop it because the data flow is already created. We don't need to keep it running. Okay, now click on the test again. Test in Cloud Shell. Hit enter. Hit enter. Okay. Now the data flow. Right now there is one caution. It says auto scaling is enabled, and for data streaming engine, workers will scale between 1 to 100 unless max number is specified. That's fine. We should get the data any second from now. Now, I just saw this dot right here. You see that? It says read from PubSub pad do. It says some data. You see the spike here? So the data should be streaming. You should also be seeing that particular chart in the last task. And that confirms the data should be able to reach the BigQuery. So let's take that. BigQuery, click on BigQuery. Here, click on the data set that we created, and then the table should be comments, details. Says streaming buffer statistics, estimated size, estimated rows, 49. So our data successfully reached the comments table in the BigQuery, which means our data flow is actually working. Now, that confirms it. After that, our next step will be saving the ML and Ansible, and running that pre-sentiment Ansible file. Let's do that. Let's go back to editor. And it says, let me close these tabs first. Okay. And in ML, pre-train sentiment.py, we need to get that code, copy from GitHub, paste it here. Okay, I think I did not create any configuration file separately for the variables, for the parameters that I'm going to pass. I think I hard coded those parameters inside the code itself. Yeah, I just did. We'll see. But firstly, let me get this code as well. Run pre-trained sentiment into this Ansible file. Forgot to copy that. I copied the name of it. Paste it here. Okay. Yes. Now we have the data in BigQuery. Now our task would be running the language model and getting the sentiment magnitude and also the sentiment score, and then saving this final sentiment data into sentiment table inside BigQuery. To do that, we're going to import language v1, which is the natural language model that is offered by Google Cloud. And then we import BigQuery to read and write the data into BigQuery. We need that module. Then we define the main function. Client equals language v1 dot language service client. We assign that to client variable, and then bq client BigQuery dot client. This particular query is right now it is just a string assigned to this variable, and that query says select comment ID, which is the ID of the comment, and comment text, which is the actual comment from YT comments 474480. I think that should be changed. Yeah, that should be changed because I think that's the project ID. Like I said, I haven't created any configuration file for this, so I hard coded these data in here. So I have to change this into the new ID. And then that's it. YouTube comments limit 100. So this basically reads the comment ID and comment text into this variable comments. Is it? Yes. And we use this bqclient.query, and this is defining this variable as query. Now this line will execute the query that we just created, and then get the data, which is comment ID and comment text, and save that data. Assign the data into this variable. Next step is to analyze the sentiment. Rows to insert. We create an empty list for row in comments. So we take one comment at a time and then document it in the way that the sentiment can be analyzed with the model. Then yes, sentiment equals client.analyze sentiment. So this analyzes the sentiment of that particular comment. Rows to insert, and then the the list we created, it will be appended with that particular comment. So by the end of the loop, it has all the comments with the sentiment score and the sentiment magnitude at the end of each row. So where it has comment ID taken from row dot comment ID, right here for row in comment. So it is taken from row dot comment ID, comment text, row dot comment text. Sentiment score will be taken out from sentiment, which is right here. After the data that we got after the sentiment analysis. By the way, I also want to mention something else. The sentiment analysis that we ran in this code is the pre-trained natural language API that is trained by Google and not us. So that it does a pretty good job with obvious comments like good job. It says, for a comment like good job, it says the sentiment score is positive. Well, the good job is a default positive comment, right? So it says okay for that. But few of the complex comments that we get in our channel might not be analyzed in the right way because this model is not custom made. If we want a custom made machine language model, we need to train it ourselves in using a Python code, but we haven't done that. We use the default model that is trained by Google, and we are using that, the pre-trained sentiment model. That's why the sentiments might be a little off. But yes, if we do the custom sentiment training, that would take a lot. But the results would be so accurate if we do the custom training. Yes. That is that, and now we give the table ID, YT sentiment. This is the endpoint where the data should be saved. BQ client insert row JSON table ID row insert. So it inserts the data into the sentiment table, and that's it. That's it for the code. Here, all we need to do is we just need to paste our project ID here, which is our source. And also here, which is our destination. Okay, this should do. And then run pre-sentiment by null. The Ansible file, for the first step, we install the Python dependencies to run that Python file. Then we run pre-trained sentiment analysis, the .py file. That's it. Nothing to talk about it. Now I copy this and run it. Okay, gathering facts is done. Python dependencies are installed. Now it is running the pre-trained sentiment. Oh, we got an error. What is it? Let me check on this error real quick. Now the error says the right here, Cloud Natural Language API has not been used in the project before or it is disabled. Well, in my list right here, I already included it, Cloud Natural Language API, but I think I missed enabling it. So it is, right now it is disabled. So we need to enable it. So the fault is on my side. I forgot or I missed it. I missed to enable that API. Okay. Now it is enabled. Well, it won't be working right away, but I'll try. I'll try to execute it again and see if it works. I don't think it will because I just activated the API, and it takes a few minutes to initialize. Oh shit. I think that should be the same error. No, that's a different error. Now it says type error. String indices must be integer, not string. Sometimes we need to reauthorize the Google Cloud service. Let me just reload this. I just refreshed my web browser. My web page. Okay. Okay, we are here. Let's run that again. Before that, I need to be in the right folder. CD. This should run. Okay. It's a different error. It again says Cloud Natural Language API has not been used or disabled. I already used it. Not sure what's happening here. I don't know. It says enabled here. I think I need to wait a few minutes, like I said, to give it the time to actually get activated. But here now it's already enabled, but yeah, we need to wait a few minutes, and I'll try that again. Okay, let's try that again now. Copy paste that. No, it should work. I went through a lot of trial and errors already. This code should work. Okay, it worked. So it took time for the API to get activated. So you don't do the mistake that I've just did. So activate this first before running that. But if you activate it while the time you ran the pretrain.py, like me, you have to wait a few minutes, basically like 5 to 10 minutes before you actually run the Ansible code. Yes, it worked, which means we should be able to find the data in the sentiment table in BigQuery. Let's go to BigQuery. YouTube comments, sentiment. So this is the data structure, details, Right here it says 49. And yep, we got all the comments saved and we can see them in the preview. Let's go through a few comments, okay? And check the sentiment score. If you see here, the first comment, great to see all your videos. Keep it up, Jay. Really appreciate your efforts. So our language, the pre-trained language offered by Google, GCP, actually is like a pre-trained model. So it detects some sort of words like great, good, good job, or thank you, something like that, and it scores with that intensity of the words. And in this command, it says great to see you, which has great in it. All your videos, keep it up, words like keep it up or appreciate it. All these words summed up, and the sentiment score goes up. So this one has a sentiment score of 0.89. Like I said, the sentiment score ranges from -1, the -1, to +1. So anything greater than 0 will be a positive review. Anything below 0 is usually a negative review. But like I said, it don't work accurately in this with these comments because we haven't trained the model with the custom comments. Usually in the real world, we train the model with our custom data. We give like 500 comments to it to train, and then when we run it, it just runs according to our comments, the previous comments that we got. So we train the model first and then we execute it. But here we are using a pre-trained model, which won't be so accurate unless it has a few words like great or good, or let's say the negative comments like bad. So they detect the words like that, the pre-trained one. And here, so this one has a negative sentiment, which means this should usually be a bad comment, a negative comment. But here it says, Jay bro, when I unpause the tag, run a tag, and auto refresh, it automatically gets turned off due to the tag was unable to run. This is neither good nor bad. It is just a doubt. So here the viewer is just asking a doubt here, and it says it is a bad review, bad comment, which is not true. Like I said, that's a pre-trained model. And here this is also a question: is it free? And it detects as a negative review, negative comment. This one has neutral, this one neutral, and negative, positive. I'm a student and you are my teacher. So for this comment, so I think at the end of this comment there should be something like thank you or something. So the score is so high. And here I really enjoyed it. Right here, enjoy. Surely be a pre-trained word. So it says, and also it has thanks, Jay. So it detects these kind of words in that comments, and it scores that comment from -1 to +1. Yes. Yep, that is it. So we got all the sentiments ready, which means we're done with the whole flow, but we need to orchestrate it. If we take a look at the architecture, we're done with the connecting the API source and Cloud Run, and then we streamed it on PubSub, and then we clean the data using data processing with Dataflow and Apache Beam, and then that data is sent through this pre-trained sentiment and got the sentiment score and saved in BigQuery, which is the business ready. Now Let's do the orchestration with Composer and Airflow. And then we go to CI/CD using Jenkins, and then we create a Power BI dashboard at the end. For now, let's go with orchestration. Okay. We need to save the DAX and Ansible for this. Well, open code editor. Open DAG. These are DAG file. This is where the DAG file should go. And again, the server, it's a GitHub server issue. We need to wait a few seconds. There you go. Okay, copy this, paste it here, and then for the deploy DAG. We copy that, paste it. The DAG. Let's take a look at the DAG code and know what we're actually doing here. Firstly, we're going to import the requirements, and also this one, which is the .py file that we already defined here. So this is going to import ml.pretrained sentiment, ml.pretrained sentiment, which is the name of the Python file, and it is going to import the main function inside the pre-trained sentiment. We take a look at this. So this is going to import everything in this function from top to bottom. So it is going to import the whole main function into the DAG just to run that. All right. If you remember, most of the process is done by Dataflow, and it is streaming, so it is automated already. We don't need to orchestrate it again here. But what we actually need to orchestrate here is running the cloud function. You remember, we need to run that the test over and over again to trigger it. Instead of that, we're going to trigger that with the DAG, and also we're going to run the pre-trained sentiment. That is also not streamed or orchestrated by any other tool. So we are going to orchestrate the pre-trained sentiment.py and also the cloud function, two of them. So these two should be the tasks of the composer. Okay, right now we imported the modules, the Airflow DAG for the DAGs, Python operator to run the Python, and their time and time delta for the time manipulation, and then import request for HTTP request. And this, like I said, our pre-trained sentiment. Now default args, these are the arguments that we're going to follow. Owner will be Airflow. Start date. Today's date is 9. If you want this DAG file to start at future date, you can specify it here. Let's say you want to start this DAG file from tomorrow. Today is 9th of October. If you want to start this from tomorrow, you're going to specify 10 here. So this DAG starts executing from tomorrow. But for now, I'm going to leave it, let's say 8 in past. And retries. If the DAG file fails, how many times it should retries? And we define the retry as 1. So it retry 1 time, and still if it fails, it says failed. Retry deploy time delta. How long should it wait before it retries? So if one execution fails, it waits for 1 minute before it retries. That's what we define here. Then define DAG. We're going to define the DAG here. DAG ID will be YD comments pipeline. Default args. We are passing these args here because we defined everything in the dictionary and assigned it to the default args variable. So we're going to call that variable here for the default args and schedule interval hourly. So this tag will be scheduled to run for every hour, every other hour. So yes, so we scheduled it with this interval hourly. And catch up false. Catch up means, like I said, if the start date is, let's say 2 days ago, and if the catch up is true, it tries to catch up, which means it takes like I said, 2 days ago. So which means 48 hours ago. So it tries to catch up, which means it executes the job 48 times to catch up. Catch up is like to catching up. That's it. So we're going to keep it false, not to spam those jobs. We're going to keep it as false. And description, this can be anything. It's up to you. And yes, until now we don't need to pass anything from this project. And the first task will be this. Trigger ingest function, cloud function. And here we need to change the project ID to our project ID. Right here. By the way, we don't necessarily need this particular line. You don't need to call the function using a link unless your cloud function and composer is in different regions. In my case, I ran the cloud function in Asia South, and the composer is running in US Central because I could not find the composer in Asia. So I ran that composer in US Central. So to refer that, you need to use this. So just if you have those two in separate regions, you need to use this, or else it is not mandatory. And then try except for the debug. If this doesn't execute, print the exception. Response equals request post, use JSON. Trigger is going to trigger, and yes, triggered injection function successfully. Print request response.text. That is that, and then we have trigger ingest function tag. So that is one task, and the second task is pre-trained sentiment. Task ID, this is the unique ID to identify the task. And then Python callable run sentiment. Run sentiment is the module that we imported from the pre-trained sentiment.py. So we are going to run that particular main function inside that here using Python callable, and that is our second task. And we are going to define the flow. And this is the flow. You need to trigger the ingest first and then execute the second task, which is the pre-trained sentiment. So we're defining the flow here. That is it with the DAG. I think we don't need to change any parameters here except for this one. If you use URL, you need to paste your current project ID in this spot. Except for that URL, everything is fine. And here, the same thing, everything's fine. This should work now. Let's run the DAG. Command for the is to run this. Let me open the composer. It is already running. DAX. Okay, it is executed. uploaded ML folder to composer DAG. Before checking here, we need to check the DAG is actually saved in the bucket. For that, let's go to cloud storage, buckets, and should be this bucket. Should be your region. After that, it says ytpipeline.com here. Inside the DAGs, you should find the files ML because we imported that. I think I forgot to explain you the deploy. That's why. Okay, here the task 1 is to upload the DAG to composer. The DAG file, which is this one, will be uploaded to the bucket, right? To the composer, which composer creates its own bucket when you create the composer. So you don't need to create the bucket separately. And when you push this DAG, it saves that in the bucket. Then we upload the ML folder as well because we need to run that pre-trained sentiment. So we need to upload that as well. That's why we have these two inside the bucket that is created by composer. Click on the ML, we see the pre-trained sentiment.py. So we have the DAG and also the ML here, which means it just takes a few minutes. Few minutes to refresh and show the DAG file actually. Well, we got an error here. No module named ML. It says. So the error here is no module found, error, no module named. It shouldn't be happening because we already have that ML. Refresh. I think it is not tracking. It is not able to track the ML folder that is saved here. But everything is fine. It should be able to track it. It's right here. There you go. Now it is tracked. So it takes a few seconds to track the other folder. It takes time to track the DAG. It also takes time to track the other folder that we pushed. Okay, now it is running. You can inspect the DAG right here, or you can just go to Airflow. I would prefer to go Airflow UI, which is a lot easier than inspecting it there. So I'm going to use that. Allow. Yes. Before we even trigger it, when we push the DAG into it, it automatically triggers for the first run and it says success, which means the DAG runs successfully. But in case if you got any error except for the ML that I just got, if you got any error right here and it says failed, now it says success. So if anything failed, this one says failed and it says how many times it's failed. You have to click on this if it is failed. So if it's successful, you need to click on this to see the DAGs and see the logs, to get the access to the logs and see what's actually went wrong. Here, click on the graph and here you will see if this one failed, it says failed here. If the second one failed, it says failed here. Now it says success. Both are successful. So it says success. And if this one fails, click on it and click on the logs. here it says what actually failed. But now everything went successful, so it says everything ran successful, but if anything fails, it should show here in the logs. Yes. That's how Airflow works. These are the tasks that we just defined and the flow that we configured. Remember when we configured the flow, here at the end it says trigger ingest first and pre-train sentiment next. That is what happened here. Trigger ingest first and pre-train sentiment next. So these two are the tasks that we defined, and they ran successfully, and this will be iterated for every hour. I mean, this will be executed. This job will be executed for every hour because it is scheduled for hourly. Yes, that is done. That being said, we're done with the orchestration as well, which means except for the Power BI, we're done with the orchestration and the whole project. And yes, we don't need to do anything with the Terraform and Ansible as well. Now, the only task that we have right now is to use Jenkins for CI/CD and visualizations with Power BI. That's it. Everything is done. For the Jenkins, let's start with the Jenkins. Okay. The next step is to create a virtual machine, right? To create a virtual machine, we go to here. Let me close the Airflow. We don't need it. On the left pane, click on it. Click on Compute Engine. Click on Compute Engine. Click on Create Instance. Here, follow these configurations. You can name it anything besides allow Jenkins, but I'm going to use the same name because why not? No, sorry. This one. Allow Jenkins. This one. We need to configure it using this one. Okay. Name, we can name it anything. I'm going to name it Jenkins VM. Jenkins VM. Name it that. It shouldn't have underscore. It can have hyphens. I cannot have capitals. Okay. Great. I'm gonna leave it at US Central. That's fine. And then switch to OS. Make sure it is at E2 to get charged less, because this is the lowest cost machine. Then switch to OS, click on change, and here operating systems, go to Ubuntu, and for the version, scroll down and go for the 2.204, which is times 86 by 64. Chose this, and that's it. Select, and then for the networking, check the boxes allow HTTP traffic and allow HTTPS traffic. Make sure they are turned on, and yes. That's it, right? This one. Yep. Okay, that is it. Now hit create, and the creation of a VM might take a few minutes. You have to be patient. Well, it won't take much longer like the composer, which took me 21 minutes to create, but this one won't take that longer. It might take a few minutes, like 5 to 10 minutes, and it'll be all set. I'm gonna pause the video and play it again. Okay, we're back. Now the virtual machine is up and running. This one confirms it. It should show the green tick mark. Now click on SSH right here. It will open a whole new terminal just dedicated to the virtual machine alone. Click on that. For the first time, it Now, for the first time, it asks for the authorization. Click on authorize and it will be authorized. Yes, you will land on that page. Let's go through the next step. Run VM initial. Don't get confused. You don't need to run VM initial. The text I meant to run VM initial file that has the commands. In the GitHub, you go to commands, VM initial.txt, copy this whole command, all these commands, run them here. Now I'm going to show you what actually the commands are doing. Firstly, it is updating the system using sudo apt upgrade. Right? Then it installs Java and Git. And the Java will be of 17 version and the Git will be installed. And then it installs Jenkins to run Jenkins UI. And then start and enable Jenkins. You need to run these two commands to start and enable Jenkins. Okay, we got something here. Which service should be restarted? Restarted. Enter the items or range you want to select, separated by spaces. Just hit enter. Okay. And then install GCP Google Cloud SDK. SDK stands for Software Development Kit for GCP. To run Google Cloud in here to authorize our actions in Google here in this terminal. We need this. Then we install Python 3 and Ansible using this sudo apt install Python 3 and Ansible, and then we install Google Cloud BigQuery and then Google Cloud Language. Which services should be restarted? What is it is talking about? I'm going to say 9. Something's wrong. Let me see. I'm going to, if you get this kind of problem, I'm going to type 0 and enter into the items of the range to select and separated by spaces. Choosing outdated libraries, up to date. I don't know what's happening. Okay, I think now it's working. All right. Hit enter. Everything you get, just hit enter. Unless it asks for yes or no. It says why like this. If any question like this happens, click why and then enter. If the question is yes or no is, if a question is a yes or no question, just click yes, or else just hit enter. It takes the default reply. Okay, this might take a few minutes right here for the processing. Like I said, if it is an yes or no question, click Y, enter. And if it's a question like this, just hit enter. Enter a path to or RC file to update, or leave blank to use this. So I'm going to hit enter. So it takes the default location. Okay, now everything is installed. So our next step would be this one, which we'll be doing in the GCP platform. Go to VPC network. On the left pane, click on the 3 lines and go to VPC network. Right here, click on it. Just slide it down. And then firewall, go to firewall. Click on create firewall rule. Here, you can name it anything, but I'm going to name it allow Jenkins. Allow Jenkins. And then targets. The targets, which is right here, the target should be all instances in the network. And the source should be this. Here with that, and protocols and ports. Select specified protocols and ports. It is already selected, and then select TCP and put in this. I don't need to copy that. 8080. Create. Okay. Now that rule is created. What's the next step? Now we can directly open this link, the Jenkins UI. Paste it, and for this placeholder external IP, the IP should be visible in this VM's UI. And we need to copy our VM that we created, this IP address, and then paste it here in the placeholder. Now run it, which should take you to Jenkins UI. First, it says unlock Jenkins administrator password, and you can get that password using this. You need to run this. All right. Wait. In here, run that, and you'll get this code. Copy that, and now paste it in Jenkins UI. Administrator password. Or save it. Here, click on install suggested plugins, and it is going to install a few plugins, and it takes a few minutes to install. Okay, for this part, I'm going to pause the video, and I will resume it after that. It's almost completed. By the way, We're just going to run one single command, one single test in CI/CD for Jenkins just to demonstrate how Jenkins works. But in actual enterprise-grade projects, we don't run the task in our main project. In order to run Jenkins, we need to create a staging project, which is an exact replica of the production ready project. The project that is in production, and there is staging project that is under that. So any change that needs to be pushed into GitHub triggers this CI/CD, and this CI/CD will test all this list of tests that we define with the staging project. So if anything goes wrong, it goes wrong with the staging project and it doesn't affect the main project. That's the whole aim of this Jenkins CI/CD. So we cannot do that right now because it takes so long to clone that project into a staging project and then connecting Jenkins and then creating these steps to run. So we're going to run a basic step with our actual project and not staging project, just to demonstrate how Jenkins actually work. And here you can skip it or you can just write random information, but you need to remember, no, not random information, but you need to remember the username and password. You need to remember the username and password whenever you want to log in into Jenkins. You're going to use that credentials. And random email random temp@gmail.com. Save and continue. Jenkins URL, yes. Save and finish. Start using Jenkins. This is the dashboard. This is the home page that you should land. Now, for the next step, save and commit Jenkins file. This will be done in the cloud platform again. Here, we will be saving the Jenkins file now. Jenkins file. Get that Jenkins file from the GitHub repository, copy this whole thing, and paste it here. And oh, by the way, I need to change the project ID because the project ID is hard-coded. Like I said, this is just the demonstration of how Jenkins actually works for the CI/CD. Check out CSN, GSA key, GCP activating service account. So we are just running this Ansible code in this Jenkins. So any push occurs in GitHub triggers this, and this is the test it runs. If this Ansible code works, it works. If it fails, the push won't be executed. So it runs the pre-trained sentiment. Okay, now we put that there and service account is there. Perfect. Save it. You can't save it. You need to push it into the GitHub. To push that Jenkins file into the GitHub, let's just push everything into the GitHub. Push everything into the GitHub, git add dot, which adds all the files, and then we git commit. This will be the final git push, so I'm going to name it. Or else I say finished Jenkins file. Let's take this Close it. Run it. Adding 24 files. Okay. Now git push origin. Ask for the credentials, your user ID, and then for the password, the API key, the access key that we stored already. We need to use that. Yes. Now we should be able to see that Jenkins file saved in the repository. Your repository. Yes, it is saved. Now for the next step, for the next step on GCP, go to IAM. We need to create a service account just for Jenkins. We go to IAM, service accounts. You know what? This cloud shell is blocking my screen. I'm going to use this other tab to run that. Go to IAM, service accounts, click on service accounts. Here, click create service account. Name it Jenkins SA. Jenkins SA. And ID will be taken, generated automatically. Leave it like that. And that's it. Done. No. Forgot to give the permissions. That's fine. Even if you are here, you can still click on that. Go to permissions, manage access, add role, add all these roles that I listed here. The first one is AI platform admin. AI platform admin, and another role which is BigQuery data editor. And then another role which is BigQuery user. Perfect. Save it. Policy updated. It may take few minutes for these changes to become active. We need to wait a few minutes. Go to IAM. Well, I can see these permissions assigned already, but usually we need to wait a few minutes. And then let's see the next step. On GCP, go to key, tab, click add key, create new key, choose JSON, create. Okay. On GCP, this one is also on GCP. Go to keys tab. Now, here it should be. Let's go to the service accounts again. Click on the service account that we created. Now here, click on the keys tab, add key, create new key. Is that it? Yeah. Click add key, create new key, choose JSON, create. Choose JSON and create. And now a JSON file will be downloaded to your personal PC. So keep it there for now. And for the next step, on Jenkins, manage credentials, add credentials. I'm going to do that. Open Jenkins. Click on manage Jenkins. On the top right, the gear symbol, click on it. And here, scroll down and click on credentials under security section. Here, click on global. Click add credential. And let me fill the details. So the kind should be secret file. So that is secret file ID. You need to copy this ID because we defined this ID in the Jenkins code. So it should be exactly matching with this ID. Paste it and then choose file. Choose the JSON file that just got downloaded. This one right here. Click open. Create. Okay, we are done with that. And our next step will be, should go to Jenkins dashboard. So click on the name, the Jenkins, and we'll land on the dashboard here. New item, name. Okay, you have to click on the new item. Name it something. I'm gonna name it YT pipeline. That doesn't matter. And choose pipeline. Click OK. And here scroll down to here, the description. Click on this drop down and choose pipeline script for SCM. All right, and here on this drop down, choose Git, and for the path, the repository URL. Wait, where am I? Git. No. Yeah, here we need to paste the repository URL. Yep, the repository URL. We need to copy paste it. This is the URL. Copy that. Paste it here, and at the end, don't forget to add git.get at the end. Then branch equals main. This one equals main. Script path equals Jenkins file. Script path should be Jenkins file. This is what we saved in the GitHub. So it says Jenkins file. That should do. And that's it. Click save. Okay, now let's go back to the GitHub. What we have to do here is go to settings. This time the project settings, not the profile settings. Go to the settings and then click on webhooks on the left pane. Click add webhook. It asks for the password. Let me type in the password first. Yes, after you type in the password, this is the page you land in. And for the next step, payload URL, http Jenkins URL GitHub. Okay, let me copy this, paste it here. But in this placeholder, we need to copy our Jenkins URL, just this part, and paste it here. Oh, we don't need the HTTPS. Okay. And also, it should be single slash, I think. Yes. This should be single slash. And then we have content type, application JSON. Should be application JSON, and then choose just the push event. We need to choose just the push event right here. And that's it. Add webhook. Now it is added, which means now click on your Jenkins job, configure, git hook trigger. Okay, there is one more thing to do. All right, we need to go to Jenkins back again. on here, click on pipeline job, configure, scroll down, GitHub hook trigger for Git SCM. In the trigger section, you will find GitHub hook trigger for Git SCM polling. You need to choose that. Choose that checkbox on, and then that's it. It should work. Then save it again. That's it. Now in this page, click on build now. Oh, I double clicked it by mistake. That's fine. To watch the logs, you need to click on these 3 dots and you can see the logs. Right now it is activating the service account, and then it's going to Google config, projects. These are project ID. Failure. Ansible playbook not found. Okay. The account is configured right. The Jenkins account that we just created, that's fine. And then Google Cloud Configure running Ansible playbook, Ansible playbook not found. What would be the issue here? Sure, but I think we need to install Ansible again here. Well, this command, this vm initial, already has this command which installs Ansible, but maybe it did not work out. So we have to install that again. I'm going to run the whole command, install everything. Reinstalled it, and I can see Ansible is already installed. But okay, let's try run that again. Back. Okay, it runs now. If you get the same error like mine, just reinstall it. Just reinstall these part, just the Ansible part. Sorry, just this part. Reinstall it. I'm not sure why that happened, but if it happens to you, just do that. Yes, just finished successfully, which means our Jenkins file is now ready. So, like I said, any push done into that GitHub will trigger this. Let me show you in practice how it actually works. This is a GitHub repository that we configured. I think you'll see anything here, but yes, if we push anything into here, let's say, let's go to GCP again, authorize. I'm going to commit a small change, just a small change. Let's say for this deploy, I'm going to add 1 space and save. Now internal, I'm going to git add all git commit. I'm going to say it as test, run it. So one file is changed. Now git push origin credentials part. And for the password, now that is pushed, which means that should trigger the Jenkins to run. If we refresh this, is it connected? Let me see. Okay, something went wrong. This should actually run again with the new build. Okay, something with the connection between GitHub and Jenkins went wrong. I should have done some mistake. Do it again. What would be the possible reason? This shouldn't be the reason. On Jenkins managed credentials, this shouldn't be the reason. And here, Jenkins file. Click on your pipeline job, configure git hook trigger JSON. Somewhere in here. Okay. Let's do that again. Settings, webhooks. Okay, it worked. Right here it says, in our webhooks, it says the recent delivers is at 21/4/2115. So this is one of this our first ping. That was the manual run, and this is the push at 9:15, which is 21:15. Yeah. So this is the run. So whenever we push something to the Git, the main branch, this will execute, and if it fails, the push won't occur. The push won't reflect into the Git repository. That is it. And the change, because that executed successfully, the change should be saved as well. What was the change, by the way? Deploy DAG. Deploy DAG should be here. Playbooks. Deploy DAG. History. Yep. Test. It is executed. So yes, whenever you push something, it triggers the Jenkins to run that test that we just defined. And if it passes, it will push. If it fails, it won't. That's how Jenkins work. Like I said, it's just a demonstration how Jenkins actually work. But yes, that is it. So we're done with most of the things. The orchestrated, the data source is done, data streaming, infrastructure as code, everything is done. The only thing left is to create a visualization using Power BI. Unfortunately, I just found out Power BI cannot connect to any table in the BigQuery if that is saved in any region other than US Central. Our BigQuery table is saved in Asia South. But if in your case, if it's saved in some other region, you can connect Power BI directly to BigQuery. But here, in our case, in my case especially, I have to use another extra tool to connect Power BI. And the link will be in the document itself so that you can access that. You need to open that link. And choose your Windows system. Well, I did not realize until this moment that Power BI won't connect to any region other than US Central. I just found out. Okay, now we need to install it. Install everything with. It says repair because I already installed it. But in your case, you have to install it. So it shows install for you. Because I already have it, it says repair. Alright, that is done. Now we need to open that. ODBC. Click on it and switch to system DSN. Add. Click on this. Google BigQuery. Finish. Data source name. Name it anything like sentiment. Description for current. And here click on user authentication and click sign in. When you click sign in, it redirects to your web browser to log you in that Google account where you use the Google Cloud Platform. You have to log in. So I'm going to log in. Wait. After you log in, they should get a refresh token by default. I mean, right after you log in. And here, click on the drop down right next to the catalog. YT comments, dataset, YT YouTube comments, and session location. Location is Asia South. Click OK and test. Success. Then click OK. Let me just pause it real quick. Then click OK. See. BigQuery data source name, BigQuery Asia South. Click on OK. Now open Power BI. Click on get data from other sources. Here search for ODBC right here. Connect and click on the DSN that we just created and extend advanced option. And here in SQL statement, I'm going to give you this query as well as part of the document. You just need to copy paste it and click OK. And here in the authentication, switch to default or custom and don't put anything inside this box. Just right away hit on connect. Now you should be able to see the data. Then click on load. So this is a temporary fix, but if you want to have the full access, you just need to create the BigQuery in just the BigQuery part in US Central or the whole project. You just need to change the whole project into US Central region. Just because GCP is more concerned about the region spec, so we have to do that. And yes, like I said, this is a temporary fix. If you want to fix it permanently, we need to create a table in BigQuery in the region US Central. Any region other than US Central cannot connect to this. We have another alternative. We can use GCP provided visualizations if you don't want to change your region from what it is actually having. And yes, but if you definitely want to use Power BI, that's the only way you can do that. It should be either in US Central region or it should be connected to this ODBC, and it can connect after to Power BI. Well, we have the data here, and by the end of the day, we have the data, so that is what we actually care of. And I really think we don't actually can create a whole dashboard with the data that we have with the columns, because we only have 4 columns. I don't think we can create a full dashboard, but we can still create visualizations with it. And yes, and with that being said, this is it with the project. Now let's have an overview of what we just did. We used YT API for the data source, and then we run Cloud Run function to pull the data out of YT API and push it to PubSub, and then we pull the data out of PubSub and cleaned it and stored it in BigQuery in a table called comments, and then that is taken out and processed. That analyzed using a pre-trained sentimental language model provided by GCP. And then the final business ready data with the column sentiment score and sentiment magnitude is added to the BigQuery final table, which is sentiment. And then we connect to Power BI. Well, that is a disaster for me because I created that in Asia South. That is a disaster. And then we orchestrated everything using Composer and Airflow. Then this whole thing is done using IAC tools like Terraform and Ansible. And then the CI/CD is done with the Jenkins. And that's it. That's it for the project. If you like the project, don't forget to follow. And I will be back with another project, probably on GCP, but this time I'm going to use more of the UI instead of using the CLI. And yes, until then, take care. See you. Adios.